Okay, so now we're going to do 14 and 15 together, and then you're going to do the rest on your own. So looking at system number 14, of course, the first thing we're going to do is number our equations 1 and 2. Now, looking at these equations, we're going to say which variable is going to be most efficient to isolate in which equation. Looking at these, I've decided to isolate n in equation 1 because looking at when I divide by 5, I know 100 is divisible by 5. So I'm going to write equation 1 on the left side, 5n plus 6t equals 100, and equation 2 on the right side, 4n plus 6t equals 92. Again, I'm going to isolate n in equation 1. Please follow along. First thing I'm going to do is subtract 6t from both sides. When I do that, I end up with 5n equals negative 6t plus 100. What's the next thing I have to do to isolate my variable? That's right, I have to divide by 5 to every single term. When I do that, I have n equals negative 6 over 5t plus 20. Give that equation a bubble and let it float up to the n in equation number 2. So now we have 4 times the quantity of negative 6/5 t plus 20, all added to 6t equals 92. Now let's distribute. I'm going to put this as 4 over 1. 4 times negative 6 is negative 24. 1 times 5 is 5. So I have negative 24/5 t. Plus 4 times 20 is 80. Plus 6t equals 92. Okay, let's combine like terms. Since I want to combine negative 24/5 t and 6t, I'm going to cross out the 6 and I'm going to write it as how many fifths. 6 is how many fifths? It's 30 fifths. So let's see. 30 fifths minus 24 fifths is how many fifths? That's right, it's 6 fifths. So we're going to have 6/5 t plus 80 equals 92. To isolate my variable, I'm going to subtract 80 from both sides. When we do that, we end up with 6/5 t equals 12. All right, as 12 over 1. T is being multiplied by 6/5. The opposite of multiplying by 6/5 is dividing by 6/5. But I know when I divide a fraction, I really multiply by its reciprocal. So the 6's both cancel out, become 1's. The 5's both cancel out and become 1's. And I'm left with t on this side. And on the other side, the 6 cancels out, becomes a 1. The 12 cancels out, becomes a 2, because 6 goes into 12 twice. And I get t equals 2 times 5, which is 10. Excellent answer, but not the whole solution, because the solution to the system is the point of intersection. So let's bring that value back up over here to have n equals negative 6/5, and instead of t, I'm going to put 10 over 1 plus 20. I'm so happy I have a 10 here because it's a multiple of 5. So 5 cancels out, becomes a 1. 10 cancels out, becomes a 2 because 5 goes into 10 twice. And I have n equals negative 6 times 2 is negative 12 plus 20. And when I add negative 12 and 20 together, I get n to equal 8. Remember, when we write our solution, we have to write in alphabetical order. L, M, N, O, P, Q, R, S, T, U, V. So I know this is going to be n comma t. So let's write our answer as an ordered pair, 8, 10, and give it some flair. Remember, ordered pair means alphabetical order. So these two equations, if graphed, would intersect at the point 8, 10. Excellent. Let's move on to 15. Looking at 15, the first thing I want to do is number my equations in my system. So I'm going to write them as 1 and 2. And what am I so excited about with 15? Take a look at that system. That's right, equation 1 already has x isolated. X equals 2y plus 4, equation 1. And let's write equation 2 on the other side, 4y plus x equals 2. X equals 2y plus 4, let's give that a bubble. Float it over to the x on the other side. So we have 4y plus 2y plus 4 equals 2. Excellent. Now let's combine like terms. 4y and 2y is 6y plus 4 equals 2. To isolate my variable, I need to subtract 4 on both sides. So I have 6y equals negative 2. To get y by itself, I need to divide by 6 on both sides. So y equals a negative divided by a positive is a negative, and 2 6 reduces to, yes, 1/3. Y is negative 1/3. But remember, the answer is an ordered pair, so I have to go back up to my x value. And I'm going to substitute in x equals 2 over 1 times the quantity of negative 1/3 plus 4. X equals 2 times negative 1 is negative 2. 1 times 3 is 3. Plus, this 4 needs a common denominator of 3. So 4 is equal to how many thirds? 4 over 1 is equal to 12 thirds. So when I add this together, x ends up being 12 plus negative 2 is 10 thirds. Let's put it all together to write our answer as an ordered pair. 10 thirds comma negative 1/3 x comma y. Write your answer as an ordered pair and give it some flair. Excellent. So that finishes 12, 14, and 15. You're in charge of 10, 11, and 13. Shouldn't take you more than 3 minutes per problem. So I'm going to be giving you 9 minutes. Please pause the video and set the timer for 9 minutes. Okay, hopefully that was enough time to pause. And taking a look, number 10, hopefully you labeled your equations in your system. It looks like I decided to isolate x in equation 2 because that was the variable that had 1 as its coefficient. I isolated x, substituted it back into equation 1 to get y is 4. Substituted that back into my equation for x and got x as negative 6, and wrote my solution as negative 6 comma 4, an ordered pair. Give it some flair. Wonderful. Let's take a look at number 11. When you look at number 11, what kind of system did you have? You end up having two equations that are parallel. There's no solution in 11. Give yourself a pat on the back if you got that one right. We had some tricky fractions in there. But when we do all the substitution, and you can always fraction bust if you want, you end up with a false statement. A false statement means there's no point that will satisfy both equations, meaning these lines are parallel with no intersection. Which is pretty cool, because then when we look at 13, we had infinitely many solutions. Meaning once we isolated, I isolated y in equation 1 because the coefficient was 1 already, and substitute into equation 2, I ended up with a true statement. That means there's infinitely many solutions because this is the same line. They intersect everywhere. Awesome. So let's take a moment and we're going to continue on to lesson 4.1e. So please pause the video and we will continue working. Okay, so looking at 4.1e, you just had to turn the page once to page 20. We're going to be applying the substitution method that we were just working so hard on. So read along, follow along as I read to you. Real-world problems can be modeled and solved using systems of linear equations. Solve the problems below. Let's take a look at Nettie's Fine Clothing. They're having a huge sale. All shirts are $3 each, and all pants are $5 each. You go to the sale and buy twice as many shirts as pants and spend $66. Read the problem again and underline the important information. Something you might have underlined are shirts are $3 each. Pants are $5 each. You spend $66 and you buy twice as many shirts as pants. So let's keep going. What are the two unknowns in this situation? What do you not know? Well, you don't know the number of shirts you buy. And you don't know the number of pants you buy. So let's call number of shirts I bought S. Let's call number of pants I bought P. Let's read number B. What are the restrictions in this situation? So restrictions means what are the details? One detail is how much money I spent. Money spent. The other restriction is the number you buy twice as many shirts as pants. And shirts cost $3. Pants cost $5. So now that we've defined our variables, just write an arrow. We're going to write two equations that represent this situation. So money spent. If I buy S shirts and shirts are $3 each, how much money did I spend on shirts? Oh, 3 times S. Plus, if pants are $5 each and I bought P of them, how much money did I spend on pants? 5P. Equals, since I only bought shirts and pants, if I add those together, the total amount of money spent. Excellent. Now the next equation is going to be about the number I bought. You buy twice as many shirts as pants. Which one did you buy more of? You bought more shirts. So this is an equation for shirts. I want to multiply by 2 because it says twice. Should I multiply the number of shirts, which I already have more of, or multiply by the number of pants, which I have less of? If I want these to be equal, I'm going to multiply 2 by the quantity that I have less of, which is my pants. Excellent. Write in words what each equation represents in the context. My first equation, 3s plus 5p equals 66, represents I spent $66. And what's the second equation? S equals 2p. What does that represent? I bought twice as many oops, sorry, you couldn't see that. I bought twice as many shirts as pants.